In this video, we will be solving an optimization problem where we want to maximize the area of a rectangle inscribed in a semicircle. If you've not already done so, press pause to copy down these guidelines for solving applied max and min problems. When you've finished and are ready to continue, press play. The problem that we'll be looking at is: a rectangle is to be inscribed inside a semicircle of radius 8. What are the dimensions of the rectangle giving the largest area? So our first step, we need to sketch picture of our semicircle. It has a radius of 8. And we're going to inscribe a rectangle in this semicircle. Now we know then that the distance from the origin to this point on the semicircle is 8. So this distance is 8 here as well. We'll call the distance from the origin to the side of my rectangle, we'll call that x. And then we'll call this width of our rectangle y. We know this is a right angle. Alright, and we want to maximize, we want the largest area, so we want to maximize area. Now for our rectangle, the area is going to be length times width. We know that our length of our rectangle, this is also x. So our length is 2x and our width is y. Now we need to write this side of the equation all in terms of x. So I'm going to use the Pythagorean theorem on this right triangle. We know that x squared plus y squared equals 8 squared. So y squared equals 64, subtract x squared, and y is equal to the square root of 64 subtract x squared. Now normally we would say plus or minus, but since we're dealing with the upper half of the circle, we're only going to use the positive square root. So let me substitute this expression in for y. I have area equals 2x times the square root of 64 minus x squared. Now I have a product, 2x multiplied by this radical, so I need to use a product rule. So my derivative is 2x times, this is the same as 64 minus x squared raised to the 1/2 power, so 1/2 64 minus x squared, and then reduce the exponent by 1, so it'll be a negative 1/2, and then multiplied by the derivative of the inside, which will be a negative 2x, plus, and then my radical, square root of 64 minus x squared times the derivative of this first factor, which is just 2. So let's This first, I can simplify here a little bit. So I have a negative 2x squared. There's an x and there's an x. So a negative 2x squared over the square root of 64 minus x squared. That's this factor. Plus, and then here I have 2 times the square root of 64 minus x squared over 1. Let's multiply top and bottom here by the radical. Get a common denominator. So in the bottom I have radical 64 minus x squared. And here I have a negative 2 times the quantity 64 minus x squared. This simplifies to this is a negative 2x squared minus 2 x squared plus 128. So I need to set my derivative equal to 0. So 4x squared equals 128. So x squared equals 32. And x equals 2 times 16 would be 4 root 2. And this is approximately equal to 5.657. So I can get my y value. Y is equal to the square root of 64 minus 4 root 2 squared. So my y will be square root of 32, which so the question asks for the dimensions of the rectangle. So the length is 2 times x. So my x value is 4 root 2, so my dimensions will be 8 root 2, and my y value is 4 root